Well, thank you. The title, with better pronunciation than me, the structure of this project is introduction, objectives, methodology, results, and conclusions. About the introduction, well, the climate change, we know that the temperature and the rainfall patterns change across the time. Temperature influence GL, physiology, phenology, and appearance of the pest and disease in the crops. This causes heat waves that at the same time cause early grapes. Thank you. That at the same time cause early grape ripening. And what happens when increase the ripening or is early? That the change of the color of the berries, high the accumulation of sugar, less the acidity, and high the grados, the alcohol grads in the wine. This is a problem because in Spain, the limit of the alcohol is 15%, depending on the denomination of origin. So when the crops or the companies want to lower the alcohol, pues, this is money, is so expensive. The most hemisphere affected is the north, where is Spain. So with this, we know that the viticulture have a vulnerability with the climate change. One of the strategies that we can use for monitoring the vineyard is remote sensing and the IA for predicting the variables like yield and ripening and another ones. Well, the remote sensing, you know, that is a technique that capture and analyze the electromagnetic radiation, and we can get this information about, with platforms with sensor in airplanes, drones, and satellites. And at the same time, we can get a multi-spectral data and do the vegetation index like NDVI, GNDVI, and NDWI. NDVI is associated with the potential of the photosynthetic, and GNDVI is with the chlorophyll content, and the NDWE with the moisture content. Remote sensing improves the efficiency because we can monitoring the harvest, the phenology, the water stress, the yield, and another variables. So the general objective of this work was evaluate the climate vulnerability in vineyards in the Ribera del Duero in Spain through satellite remote sensing techniques. This in order to see the health of the crops. The specific objectives was first, evaluate the climate vulnerability using 3 vegetation indices. The second, monitoring the temporal and spatial evolution of the crops healthy in the 2020, 2021, and 2022. This focus in the summer part. And final, analyze the correlationships between vegetation index and climatic conditions. About the methodology, well, the study area was in Peñafiel, that we have the most of the vineyards here in Valladolid, in the denomination of origin Ribera del Duero. And we take aleatory 356 hectares and take information from July 1 and August 30 in the 3 years, 2020, 2021, and 2022. This is according with the fruit ripening. That is the most sensible to the temperature. And we use the satellite image like Sentinel-2. And in this part, we have the map. No tiene el code. Sorry. Yeah, in this part, we have the map of Spain. And in almost the center, we have the denomination of origin, the Ribera del Duero. We take aleatory, the area that I mentioned, and have in this area, in this part, we can see the plots with vineyards, number 1, number 2, until number 10, that is in this part. So about the workflow, we take Sentinel, we work with Sentinel-2 from the dates that I told you, from Copernicus, and we get the climate data about the State Meteorological Agency in the same dates. We use the tree index, and finally we create the maps for see the dynamic. Well, about the results, first we have the index average year per year, year on year, and second the index intra-annual. Why intra-annual? Because when we get or we download the image from 1 of July and 30 of August, we have this sense or image without clouds. Yep. Well, the first is NDVI, that is analysis of the photosynthetic activity, average 2020, 2021, and 2022, we see. And the first that we can see is that the plots of the center of the map have more vulnerability because have index is so low. So is most vulnerable this part of the area. Some authors say that high temperature is high stress, less photosynthetic because of the stress, and possible less production or quality of the fruits. Yeah, in the center we can see that have more the index that is when it's red is more stress, and when it's green is less stress. The plots that is green is another crops. And when we get one plot, for example, the number 3 that is affected have more the color, red color, and evolution the 2022 until 2022. And we can see that the focus of the problem is first in this part, and evolution to all area. Possible is because have problem of the nutrient deficiency, water stress, no covers, or some agronomic practice that low the index or affect the index. We have here the GNDVI that show like the same because is the chlorophyll content that is relation with the potential, the photosynthetic potential. And low GNDVI probably is associated with a low content of nitrogen in the soil. So we can see that at the same time, the same is in the center of the area. This is more vulnerable. And some authors say that the GNDVI is associated with high temperatures. We can get the plot number 1, and we can see the advance of the problem, and is more intensive in the last year, in 2022. In this part, we can go to the crop and see what is the problem. Now we have the NDWE that show the moisture content that is relationship with the other index that is low, the index photosynthesis, photosynthetic, chlorophyll, and now is because don't have water. And we can see the same problem in the center of the plot. So low NDWE, low moisture content, low water retention for the soil, less access to the water from the soil for the crops, and less activity of the photosynthetic activity and chlorophyll content. And if we do some to a plot, for example, the number 3, we can see a problem, but in the beginning of the years was more intensive because the NDWE was more negative or more red, the plot. Now we have here the intra-annual monitoring. We can start with NDVI in the 2020. I only will show you the maps that have a little difference because with all maps, sometimes I see the same color, but I will only show the maps that represent some change. So in this year, we can see that in the days, the year 2 is a date, but we can choose the days that were most intensive the stress. For example, 5 days before they get the image, and at the final that have the low NDVI too. Maybe we have here problems like deficits, no fertilizer, phytotoxicity, and another ones. And here I have all the database about the NDVI per plot and per date. The R is the date. So here we can choose what is the plot more affected, and the decision is go to the crop and localize the plot and the area that is affected and recognize the cause. And here have the G NDVI. We can see like in the beginning of the time to July and end to August, have a problem in the beginning. Maybe it's for some practice, no irrigation, problem with the soil. So we don't have in this project the access to the data in field. So this is only with images. And at the same, we have here the data from this, and we can decide, well, load the index, and we can go to the crop and see what is the problem. At the same, with the DNDWE, the 2020, that represent that in the final of on the intermediate and in the final of this period, have a problem. Maybe it's sorry for my English, may indicate a drought in this time. Yep. Well, and well, the data that we can take decisions, and we can go to do the zoom and locate the problem, if it's in what part of the plot and what kind of the solution we can do, for example, an irrigation problem or another kind of problem. And the final, we have the spectral results and climatic variables. That is so basic because we need to check more years and more information. So we have in the year 2022 that we saw that was the year most affected, have the high temperature in comparison with another years, and the low precipitation in comparison with another years. That's the reason why the last year was most affected. And about the correlationships between vegetation index and climatic is that correlation positive between index and precipitation, but no difference significatives, and a correlationship negative with the temperature and the index, but with a significant difference between GNDVI, NDVWE, and the temperature. The next step of this project is use models of prediction of harvest in these crops and include the data base in the project. Because now I say again, no, we don't have data in the fields, and some properties of the soil. And working with images that have more resolution, for example, with planet that have 3 meters of the spatial resolution, and do a sonification. So now we have the satellite images, we have the index, but we don't have the data in the field, and we need to analyze more the data in order to predict the yield. Like conclusions is first that the vulnerability of the crops is with NDVI that indicates that low NDVI suggesting a possible water stress, and the temporal trends with GNDVI reflecting a possible water stress. And the water stress monitoring with the NDWE indicate significant deficiency of the water. About the correlationships, now we see the NDVI and GNDVI have negative correlationship with temperature, and the 3 index have a positive correlationship with the precipitation. And thank you so much for your attention and your patience with my English. Thank you so much.